Hey guys, Mr. Milton here. Today we're going to look at trig ratios. At the end of this video, you should be able to identify the trig ratios in right triangles. And you should be able to find the side lengths of right triangles using trig. Okay. In any right triangle, there is one right angle and two acute angles. In this case, the right angle. In this case, the right angle is angle C, and the acute angles, angle A and angle B. Okay, in the trig we will be looking at today, you must have a right triangle. Okay, so it only works in a right triangle. But the trig ratios are found with respect to the two acute angles. Okay, we'll look at three trig ratios today: sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated TAN. Sine, cosine, tangent. Okay. Each of these refers to ratios of certain sides of the right triangle with respect to a certain angle. Okay. The sine of angle A, we write that as sine A, is a ratio of the length of the opposite side of angle A over the length of the hypotenuse. So as we look at here, notice that as we label our triangle, our angle is capital A. The side opposite that angle, we call it side A, lowercase a. Our angle is capital B. Side opposite is side B, lowercase b. Our angle, capital C, side across from it, we labeled as C, lowercase c. Okay, so sine uses the opposite side over the length of the hypotenuse from angle A. So as we look at angle A, from angle A, the opposite side to A is A. And the hypotenuse of this triangle is C. So sine A is just side A over C. Okay, our trig ratios. Sine of an angle is always the length of the opposite side over of that angle over the hypotenuse. Cosine is always the length of the adjacent side over the hypotenuse. And tangent is always the length of the opposite side over the adjacent side. All right. So it says write each trig ratio using the figure above. Zoom out so we can see all that. Okay. So sine A, we've already done that, but we'll do it again. It's the opposite over the hypotenuse. So the opposite would be A. The hypotenuse would be C. Okay, cosine A, again from A, our cosine is the adjacent side. That's the side that's next to our angle. Okay, and now you might say, well, there's two sides that are adjacent to angle A. And that's true, but C is the hypotenuse, so we just always label that the hypotenuse. So the adjacent side B over the hypotenuse C. And then tangent A is the opposite, which is A, over the adjacent, which is B. Okay, and here we're just looking at setting up these ratios of their sides. Okay. Now, if we do the same thing with sine B, so now we're looking from B's perspective. Sine would be the opposite from B, which is B, over the hypotenuse C. Cosine would be the adjacent, again, that's A, over the hypotenuse, C. And tangent would be the opposite over the adjacent, B over A. Okay. You'll notice, hopefully, that the sine of a particular angle is equal to the cosine of the other. So you see that sine A is equal to cosine B. They're both A over C. Sine A, cosine B. The sine of A is equal to the cosine of B. Notice the tangent of a particular angle is the reciprocal of the tangent of the other angle. Okay, now right now that might seem like, wow, that's a lot to remember. How do you remember what those ratios are and what order they go in? Okay, and the way that you can remember the way I remember what order those go in for the ratios is acronym, and it's just TOA. Okay, and this acronym just tells us basically how our ratios are set up. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay. My high school geometry teacher told me, I don't even know what to call it, a saying, kind of the same way because I was having trouble remembering this, and it was, some old hippie came around here tripping on acid, and I never forgot it. Okay, so all that is just a mnemonic device to try to keep your ratios set up in order. Okay, so it says write each trig ratio from the figure below. You must always simplify your ratios and put them in simplest radical form. Okay, so no radicals in the denominator, please. All right, so here they gave us AB is 10 and BC is 15. You'll notice this, our first question just asks us what AC is, okay? You might say, well, they didn't give us that, but it's a right triangle, so we can use Pythagorean's theorem to figure that out. So Pythagorean's theorem, A squared plus B squared equals C squared. So we'll say 10 squared plus, don't know what B squared is, that's AC, equals 15 squared. It's 100 plus B squared equals 225. Subtract 10 from both sides, or sorry, 100 from both sides. And so now to take the square root, 5 times 25, 5 and 5. So you have a pair of 5s and a 5 without a pair, so it stays inside. Okay, so AC is 5 radical 5. Okay, so now we're going through, we're writing these ratios. Cosine of B, that's adjacent over hypotenuse. So we're at B, the adjacent is 10. The hypotenuse is 15. Simplify that, 2 over 3. Tangent of B, that's opposite over adjacent. So that's 5 radical 5. That's the opposite from B. The adjacent is 10. We can simplify, we do, and so we can. Radical 5 over 2. And then sine B is opposite over hypotenuse. So we should have 5 radical 5 over our hypotenuse 15. 5 goes into both of those, so we have radical 5 over 3. All right, looking at C, and so cosine C, again looking from C, so cosine's adjacent over hypotenuse, 5 radical 5, that's our adjacent, our hypotenuse is 15, so 5 goes into both of those, radical 5 over 3. Tangent C, opposite over adjacent, so that's 10 over 5 radical 5, and so now I see that I'm going to be running into having a radical in the denominator. Do that over here. 2 radical 5, remember we cannot have radicals in the denominator. In order to get rid of that radical in the denominator, we have to rationalize this, and if you learn from me in Algebra 1, you know I call it fancy 1. We are multiplying, we're trying to find out how we can get rid of this radical in the denominator. The easiest way is just to multiply it by itself. Radical 5 times radical 5 gives us radical 25, which simplifies to give us just 5. In our numerator, 2 times radical 5 is just 2 radical 5. So simplest radical form is 2 radical 5 over 5. Okay, and then sine C, that's opposite over hypotenuse. Opposite's 10, hypotenuse is 15. 10 over 15 simplifies to 2 over 3. And so our relationship held up. Cosine B is the same as sine C. Okay, we never have trig ratios with the right angle. Just going to point that out, that you'll notice we looked here from angles B and angle C. Okay, again, the two acute angles. We don't look at from the right angle. Okay, and the reason why the side opposite angle A is also the hypotenuse. Okay, so looking at the right angle kind of takes away those sides from us a little bit. Okay, also when we're looking at the side that's adjacent to A, both sides would be adjacent to A. So earlier we were like, hey, we can kind of skip the hypotenuse because it's already the hypotenuse. We won't get it confused with the adjacent side. But here we would. So we will never look at trig ratios from the right angle. Okay, so now we got those set up. Let's talk about using those to solve for those trig ratios to solve for missing lengths. Here it says find the length of the indicated side, round your answer to the nearest tenth. Great. So we want to find x, and they gave us this angle 53. Okay, here's how we can use our trig ratios. I'm looking from the angle that I know is 53. I'm going to label my side. This is an opposite side, right? This is the opposite side. This is the hypotenuse. This is the adjacent side, right? So opposite side that it's looking at. Hypotenuse, the side across from 90-degree angle. The adjacent, the other side. So what I'm looking for is, I'm looking to see what sides do I know. I know the hypotenuse. What side do I want to know? I want to know the opposite. So look at here so I can reference it later. So since I want to know the opposite and I know the hypotenuse, the only ratio that has opposite and hypotenuse in it is sine. So I know I'm going to be using sine here. Sine, and instead of saying like angle A or angle B, I know this angle measure. Sine of 53 equals the opposite x over the hypotenuse 15. Okay, now we'll use our calculators with this, so make sure you have your graphing calculator handy with you this chapter. And sine 53 is actually a number. So am I here? Trig sine 53. All right, so I have to do it like this way. All right, so sine of 53 is an actual value. Okay, all these numbers. Okay, and so your calculator has that memory, or that in its memory, so you don't have to keep it there, but that's a ratio that's going to stay consistent throughout right triangles, and that's why we can use that. And so what we'll do to find x, or to solve for x, is just solve this problem now. Okay, I'm multiplying both sides by 15, and so I have x will be 15 times sine of 53. Which I can do in my calculator. Sine 53 times 15, and that gives me 11.97. So it says round to the nearest tenth, that should be 12. 12.0. Okay. Looking at the next problem, they ask us to solve for B. So again, we're looking from this angle because we know it's 25. We're going to identify what sides we have. So here's my opposite side. Here's my hypotenuse. Here's my adjacent. So I want to know the opposite. I know the adjacent, opposite and adjacent. That means I should be using tangent. So I'm going to say tangent from the angle that I'm looking from, 25, equals opposite B over adjacent 8. And then I solve this problem, okay? Using algebra from here, multiply both sides by 8. And so I have 8 tangent 25 equals B. And now that I have that set up, now I can go to my calculator 25 tangent, that value times 8. Times 8. All right, and so that is 3.7. Looking at our next problem, we have number 3 here, 88, 146, and then H. Notice in this problem, different from the other 2 problems, this is not a right triangle. Okay, we will not be able to use our trig functions for this. Actually, we'll revisit this towards the end of the chapter when we talk about law of cosines. Okay, but we will not be able to use trig functions for this because it's not a right triangle. Okay, and then number 4, we've got a right triangle. Great. And then they ask us to find A and C. So it's going to be 2 separate equations here. Let's look at our sides and label them. So from this angle that we know, 30 degrees, this is our adjacent side, this is our hypotenuse, and this is our opposite side. So if I'm solving for A first, I know the opposite. I want to find the adjacent. Opposite and adjacent tells me to use tangent. So I'll say tangent 30 equals opposite 7 over adjacent A. Okay, as we saw for that, and I'll do that up here, I want to get A by itself, but A is on the denominator of our fraction, so it makes it a little bit different. Not difficult, but just different. Okay, I want A out of the fraction. I want it out of the denominator. So what I'm going to do is I'm going to multiply both sides by A. So A times tangent 30 equals 7. And then I want A by itself. Remember that tangent 30 is a number. Okay, so we're not going to divide by tangent and then divide by 30. We're dividing by tangent 30 on both sides. So we have A equals 70 divided by tangent 30. In our calculator, tangent 30. .577. So 7 divided by 0.57735. And that gives me 12. All right. And then the next one, they ask us to find C. And so again, we've already identified this is the opposite. This is the hypotenuse. Opposite and hypotenuse tells me to use the sine function. So I'll say sine of 30 equals opposite 7 over hypotenuse C. Okay. Multiply both by C because I want C out of the denominator there. C times sine 30 equals 7. Divide by sine 30, so C equals 7 divided by sine 30. 7 divided by sine 30. That should give us 14. And that is 14. Big thing to remember here, SOHCAHTOA. Okay, and that's just our way to set up our trig functions. And as you get through, or going through these, I think that'll come to be kind of like second nature to you. All right, see ya.